My name is Mary Biddle-Koenig, and I'm the Assistant Director of the Smith Enterprise Risk Consortium, or CERC as we call it, at the Robert H. Smith School of Business at the University of Maryland. I would like to welcome you today to the September webinar of our monthly Risk Leadership Series, which is brought to you by CERC, ZRG Partners, and the Office of Executive Education at the Smith School of Business. Today's topic is extreme weather events in 2023, a harbinger of accelerating climate risk or unusual weather patterns. Just a few housekeeping items before we get started. First, a quick reminder that today's call is being recorded and will be posted on our website shortly. Also, thank you to all of you that sent questions in advance during the registration process. If there are additional questions that people would like to pose, please put them into the Q&A at the bottom of your screen throughout the discussion, and based on timing, we will do our best to address as many of these questions as we can. Now, I would like to introduce the Director of the Smith Enterprise Risk Consortium, Cliff Rossi, who will be our moderator today. Dr. Rossi is a former risk practitioner with decades of experience in risk management at some of the largest financial institutions, and he is now at the Smith School of Business. He was instrumental in the launch of CERC on June 1st of this year, and now I'm pleased to turn it over to him to get us started. Thank you very much.
Thanks a lot, Mary Biddle. And as you said, we're really pleased to host this latest installment of our CERC Risk Leadership webinar series on extreme weather events with this expert panel today. We'll get into it in just a second. And as everybody's probably familiar with, particularly seeing the news this morning of all the New York City flooding that's going on. But it's been nothing short of eye-opening for many non-scientists like myself that have been watching the news over the last several months in terms of Canadian wildfires, the devastation in Maui, drinking water issues in New Orleans, excessive heat, and drought out west and the like. So what we're going to do today with this expert panel is examine these extreme weather events from the context of the intersection of science and business, specifically kind of looking at that intersection with science, finance, and risk. And for that, we're elated to have Dr. Sarah Kapnick, who is NOAA's chief scientist with us today, along with two of my CERC colleagues, Dr. Robert Brammer, who is one of our executive risk fellows, and Professor Tim Canty, who is a professor of atmospheric and oceanic sciences at the University of Maryland. All three of us work very closely together on this issue of the intersection between science and business. So I'm happy to have all of you joining us today. Thank you very much. I'd like to actually get things kicked off here. We're going to have a series of questions, as Mary Biddle said earlier, with the panel, and we're going to reserve somewhere around 10 minutes or so toward the end to take questions from the audience. But for the time being, just sit back, relax, and we'll have a conversation about all things relating to extreme weather. So I'd like to kick things off with you, Sarah, if I could, and how we should be thinking about these events generally from your vantage point at NOAA. That is, and again, I'm a non-scientist here, but are we seeing these as a series of events from some natural climate phenomena such as La Nina, or is it related to other longer term trends, or is it something else? What do you make of this?
Yeah, so first of all, the changes that we're seeing in extreme events, there's tremendous amount of science behind how those probabilities are changing, as well as how the magnitude events are changing due to climate change. So in the last 10 years, that science has really exploded, of being able to actually, with the observational data that we have, but also with the climate modeling we have, be able to generate enough information to understand what those risks are over time and how they're evolving. So we are seeing the increase in magnitude as well as probabilities of events, particularly heat waves, particularly extreme precipitation events like what we're seeing today in New York. Those are very closely linked to warming and to change. And so we know that these risks are changing, they're evolving, and they're increasing due to climate change, along with that steady march of emissions into the atmosphere. Your question on El Nino is also important because there are extreme years. And we are starting to have our El Nino. It was declared in June. It will peak next winter. In the like February, March, April timeframe. And so we are going to continue to see certain types of extremes also driven by the El Nino. So an El Nino is an extreme year on top of many years on the steady march up. Also importantly, with an El Nino, And global temperatures during an El Nino increase above the average by like 0.1 degrees roughly for the entire year. So on top of this long-term warming, you have this extra nudge up, which also happens to be roughly a decade of what the warming signals typically has been. So an El Nino also is an extreme year on top of the warming, but it also gives you a glimpse into what those extremes look like for the years to come over the next decade. And then 10 years out from now, we'll say that this year, this warming, this will look cool or average by comparison as we continue to have warming. So there's this context that we have this long-term change, but we also have these extreme years where you can have additional events, additional types of climate and weather phenomena experienced during that extreme. But in the future, because of these trend lines, this becomes the norm in the future. So it's a glimpse into what our future also looks like.
That's a little unsettling to say the least. Tim, this issue that Sarah's talking about with regard to kind of climate and weather, I know you and I've talked about this a lot. You speak a lot about these things. And so I'd be interested in your thoughts about maybe telling the audience a little bit about this issue of this short versus long term and making sure that we understand what weather is versus climate.
Yeah, weather is, today it's this season, and this is a problem, I think, in the communication and how people approach this topic is they think weather and climate are the same thing. Weather is short term, climate is much longer term average. And we can see when a severe weather event happens to try to attribute this to a changing climate. It's almost, we realize it after the fact, like, oh yeah, there was this long trend, and we can see looking backwards, this was happening. What this means for the future, though, is a big challenge. If I could predict the future, I'd probably be retired right now. But and in communicating these risks, everyone wants to know what's going to happen the next 10, 20, 30 years, the lifetime of a mortgage, perhaps. The climate models are very different from the weather forecasting models, and that you're not going to be continuously running a climate model that will tell you exactly what's going to happen in the next 10, 20, 30 years. The climate models are really designed to show changes in the long term. But what we really need and what we're really trying to focus on is to translate the climate models into this kind of mid-range seasonal, sub-seasonal forecasting, if you will, or prediction. So the climate models won't tell you what's going to happen on a particular date 10 years from now, but understanding the physics of this system can give you an idea. And looking at natural variations like El Nino now as a predictor of what will happen in the future, it can give us a better idea, not exactly what date it's going to happen, but what we should be prepared for and kind of the timescales we should be focusing on.
Interesting.
I want
to go ahead, Sarah.
Add that. So I would, to add some nuance to what Tim was saying, is there's a tremendous amount of innovation occurring at the seasonal to decadal prediction timescale. And so one thing that Tim is saying is that the use of projection information that were developed for the IPCC, the global understanding of climate, those projection informations are not necessarily predictive for the next 2 years or the next 10 years, the way that they're constructed. There's massive amount of innovation happening that US is leading on in terms of seasonal prediction and being able to predict things, which goes from 4 weeks out all the way to 2 years by the Weather Act. We actually have, it's a research program called the North American Multi-Model Ensemble, but it's run in an operational sense every single month. And that feeds our seasonal predictions of El Nino, of winter weather in terms of temperature and precipitation, flooding in the spring, and our hurricane season. And there's predictability. The research is showing that there's predictability several months to 9 months in advance for heat waves, for atmospheric rivers, for all these other things. And so there's a tremendous amount of innovation right now, and those are being translated over time into products that we will have. So we will have a lot more information in the coming months, years, that will further develop and increase the skill of some of those predictive capabilities on short term. And I think it'll be a really interesting area where you see the financial markets and others start to incorporate that information, but it's super new. But it's not It's not science fiction that is going to further develop over the coming years, that we will actually have that information. So the climate models and the models that are being developed now and in the future are going to answer some of those questions and are actually being designed to be able to serve that better.
I want to come back to this in a little bit, Sarah, on this. I want to come to Bob first, and then come back to this issue about this kind of taking this science that's happening right now, because as we know, it's difficult for like banks and others that are doing these climate scenarios to try to integrate that physical output information directly into their financial risk models, kind of for those projections that they have to do. But so hold that thought. I'm going to come back to that in a second because it's very important. But Bob, before I do, one of the things that I know you and I've been spending a fair amount of time talking about, and you've been researching quite a bit about, are kind of like these really bad outcomes out into the future, these so-called tipping points. You hear about this or read about this in different places, and so it'd be interesting if you wouldn't mind walking us through what these tipping points, what we're talking about here with that, and how could they affect our physical and socioeconomic systems? What are these things all about?
Okay, yeah, thank you, Cliff. I want to distinguish tipping points from extreme weather events. They're not the same thing. Extreme weather event may be fairly short term, a hurricane or a flood or something. A tipping point is a threshold in the climate system, whereas if conditions exceed the threshold, then there can be a long-term permanent change in the climate. And historically, there have been many tipping points going back centuries. And so the formation of the English Channel was a tipping point, which had significant impacts, or the channel between the Black Sea and the Mediterranean is having strategic implications even now with the Ukraine war. But there are a number of possible tipping points that could occur in the next decade or two. Now, this is controversial. Some models would say that major tipping points are still maybe 50 years or more in the future, whereas other researchers have said there is a probability, it may be small, but if it does happen, the effect would be very significant. And this could be a warming in high latitudes, which would release methane, which would increase global warming. There could be a big chunk of the West Antarctic ice sheet falling into the ocean, which would cause sea level rise with consequent flooding risk. There could be changes in the Atlantic Ocean circulation patterns. So there are a number of possible tipping points that, even though these are low probability events in the next decade or two, if they do occur, the impacts would be very significant. And that brings me to a point I wanted to make about how companies are preparing now. A recent analysis of all of the public filings of the S&P 500 companies shown that while most of them are saying something about climate change risks in their annual reports or 10Ks, relatively few are talking specifically about their resilience planning. And so I think that is something that the improvements in the modeling that Sarah just talked about needs to be communicated more readily and effectively into industry, because we've already seen what wildfires and tornadoes and so forth can have effects on significant companies and their assets. So this is a significant business issue, and it goes well beyond theoretical scientific predictions to significant impacts on the finances of the major companies and the economy of the U.S.
Yeah, no
Can I-
doubt. So, mhm.
Yeah, and adding to Bob, the S&P put out a report of the different sectors that have adaptation resilience plans. And besides insurance reinsurance, because they see this as fundamental to P&C insurance, you see it the most in the utility sector. And you see it in the utility sector post bankruptcy of PG&E, where they're trying, particularly on wildfire, but it's also increasingly it's storm surge, it's sea level rise to anything that's coastal. For their infrastructure. It's also hail. This past summer, there were a lot of hail damage due to severe storms across the nation, and they saw that problem with solar cells. And actually, NOAA, as part of that, we developed an MOU with EPRI around bringing climate information into both business resiliency planning, but also long-term investment planning. Because increasingly utilities are seeing it as a need for their energy security. And so I think it's interesting, you can see it happening in certain sectors that have had losses or have had very public losses. There are questions in those industries of what are you doing? And so those are the first to start developing those adaptation resilience plans. And I think that trend, as Bob said, will continue.
That's interesting, Sarah. I mean, I'm intrigued about the comment about insurance and reinsurance, because as we all been hearing about, right, some of the large insurers have kind of either pulled out from writing new policies, and I know the GSEs, Fannie and Freddie, are quite concerned about the implications about availability and cost of hazard insurance or homeowners insurance for their borrowers. And it's like, has NOAA been working with the insurers like you mentioned with EPRI and others? Is there something down the line for that coming along?
Yeah, the insurance reinsurance industry has been a big partner and stakeholder that we talk to regularly. And actually, we have held both roundtables with insurers, reinsurers, but then we also, out of those roundtables and discussion, there was a desire to know what the most cutting edge science is or that is coming online that might be of use. And so we held a series of monthly webinars with our scientists explaining the cutting edge science on specific topics like hail and severe storms, hurricanes, sea level rise, extreme precipitation. So we're holding these because there's a desire to have that interaction of what is the newest in science and why do you know what you know and what do you think the future of the science is. And then also from those roundtables, from those monthlies, but also from our knowledge of how climate information is integrated into those business models, particularly catastrophe models. With our IRA funding, we are funding a series of IUCRCs led by National Science Foundation. So it's a vehicle that they have. It's an industry university research centers. And so it is competed, and we actually have all the applications now. It's competed, a bunch, consortiums of universities come together, they apply for it, but then they also bring in the private sector, and the private sector also jointly funds it as well. And so the goal of it is you develop the fundamental science and information around what the center topics are that we've requested, bringing climate information into catastrophe models. It also trains a new workforce in this space, and it spurs innovation, and it also creates this vehicle that the universities now are actually are able to talk to the private sector and to get feedback so they can create use-driven science and R&D. And so this came out of this clear need that there needed to be discussion, there needed to be advanced rapid innovation in the space. And so we brought everyone together with this structure with NSF, and I'm really excited to see that us be able to make the selections, put the money out, because it is really a big topic in the insurance reinsurance space, and this need to help figure out how to bring in more climate information into the catastrophe modeling for going forward.
I would say the same thing would hold true for, let's say, again, I'll just say GSEs from a mortgage standpoint, because that's the largest, asset that most people actually have in their lives. And, both of those companies are sitting on top of an enormous amount of insured credit exposure there.
Well, yeah, and the importance of it in the catastrophe models too is its total value at risk.
Yes.
So you may have growing peril problems due to severe weather, but if you're in a coastal zone, you might also have hurricanes or sea level rise or storm surge. And so it brings in together all that those different types of perils, different types of information into your total value at risk in a given year or a given time period. which I think is also, I've been communicating to the scientists, it's a different question than what is the likelihood of extreme precipitation changing, because when you're trying to make those financial decisions, you need to be able to bring it all together. And so I think that there's going to be a lot more on that going forward.
Yeah, certainly with the banks, right? Community banks that have small geographic footprints that are exposed to kind of large natural perils. I mean, I can see a lot of work that needs to be done in kind of getting people educated in this space. You know, those of us that come from either the finance or risk areas, we're not scientists. So trying to find this intersection, I think that's where Bob, Tim, and I have kind of been working together. And as I tell them, they're kind of slumming it with hanging out with me as an ex-banking guy. But Tim, what do you make of this?
I find tremendous scientific opportunities in all of this. A lot of this innovation we've been talking about is driven by recognizing the needs of these stakeholder communities and trying to answer questions. We may not have the tools developed yet. We may have the capabilities, but you have to first identify the problem, then say, okay, how do we solve this problem? That requires a lot of feedback and engagement. But it's also a tremendous opportunity, just speaking from the academic side of things, that there's a lot of opportunity to drive pure science, which is what some scientists really want to focus on, but also opportunities to not just recognize current needs, but also identify future needs that people may not be really thinking about yet, or the kind of the cascading effect these events may have. The wildfires in Canada this summer, you mentioned earlier, obviously led to some of the worst air quality we've seen in the East Coast in decades, and we had some of the worst air quality in the world. Well, the cascading effect, well, what was the run on hospitals in community urgent care centers with asthma attacks? How many missed days of work were there? So really trying to identify the full economic cost of some of these events. I'm not quite sure has happened yet, but things people don't always think of until we start talking about them and think, well, oh, duh, yeah, that makes a lot of sense. Recently, I've been working with the Coast Guard because they're concerned that bridge clearance is shrinking as sea level rises. Bridges don't rise with sea level, but a lot of the major shipping concerns are increasing the size of their freighters to kind of lower their carbon footprint. So freighters are getting bigger while bridge clearance is getting smaller. And so there's a crossover point. And once you start identifying that, like, oh gosh, we've been low-hanging fruit, sea level rise, inundation, but how are we going to get ships into the Port of Baltimore or other ports if they can't get out of their bridges, or they're going to have to park until water levels go down again? This isn't included in permitting processes, and this is going to require a lot of innovation in the tools we use, but innovative thinking in how we address these tools or how we address these problems as they occur.
Yeah, I mean, one of the banking regulatory agencies today, right? The Fed's conducting this pilot climate scenario analysis with a handful of banks, and trying to understand the stability and the safety of the banking system as a result of these against extreme weather events or climate change. In fact, I think one of the events that they have dialed up is assume that you have a large hurricane that hits the northeast region of the United States. What impact would that have on your credit portfolio? So I guess a question to all of you would be, what spatial resolution and accuracy improvements can we expect in, let's say, seasonal and interannual climate models in the next few years to improve, the kind of testing, the climate-related testing that we have to do on occasion in the banking system? Anybody want to take that one on?
Yeah, I think the issue there is the mismatch between the current generation of climate models in terms of their resolution and both spatial and temporal resolution, and what the banking system really needs. I mean, the current banking standards set by the Dodd-Frank Act 10 years ago require the banks to make forecasts for capital reserves over the next 9 quarters. Right. That's 2 years. Most climate models are set up to model effects over decades, and with spatial resolution that is far larger than the asset level resolution that the banks would be lending for their bonds and mortgage issues and so forth. So what Sarah mentioned a little while ago about the seasonal and interannual modeling is tremendously important. And what we need to get is a much finer resolution, both spatially and temporally, in order to really provide credible information that the banking system can make for their capital reserves.
Yeah, that's a great point. Tim?
Yeah, but also to recognize, we would love to run all of our models at, 10 meter, 1 meter resolution, but the computational costs don't scale linearly. And this is one of the big problems we have. It's not just simply writing a better computer model, it's access to computational resources. And, recognizing these large global climate models, to run them at finer resolution right now, we may not just simply have the computational capabilities, but this is where regional climate models can be brought in and run at higher or better spatial resolution. And just as an example, recently, and Sarah, of course, correct me, but the Environmental Modeling Center at NOAA received a 20% increase allocation of supercomputing time. And I think what I heard, that allowed them to go from 12-kilometer resolution to, I think, 9-kilometer spatial resolution. So and I was on an external review committee for the Environmental Modeling Center, and this is what we keep hearing. We need computational time. This is always pushing the innovation in terms of supercomputers. We just need more computing time. There's ways you can downscale the climate models, but it's always some form of interpolation or extrapolation, and there's always the uncertainties that go along with that.
Yeah,
I'll say not only computational limits, we don't really understand the physics and the chemistry of that resolution, nor do we have the observational density yet. Although we are taking steps with the various mesonets and micronet developments, that will help improvements in computing systems. But the dynamical modeling in the regional models, 9 kilometers is still huge compared to the size of the assets that a corporation is concerned about.
So if we only cared about what is the change in temperature and heat, it would be a simple problem where it scales much more easily with statistics, with dynamical models down from the global information. But the problem is we're not just interested in heat, we're also interested in extreme precipitation, severe storms and hurricanes, and where are fish going to go under climate change? And so depending on the question, we need to construct different modeling systems or groups of modeling systems to answer those questions. So we are advancing the capabilities of the modeling. Like there's another injection of funding through IRA into climate ready fisheries to improve the resolution in the ocean, but then also be able to do all those simulations to understand too, where did the fish go, but also what is lost in those low resolution models and those information versus the higher resolution when we really push it to the limit. And similar things are starting to happen in the atmosphere with trying to say, okay, what is the future of extreme precipitation? And increasingly from the analysis that we're seeing, there's some work out of our geophysical fluid dynamics laboratory in Princeton, New Jersey. There's also work out of the UK Met Office that suggests when you move to these higher resolution models, when you go to 25 kilometers, you go to 12 kilometers, you even go to 3 kilometers for the short runs that we've been able to do, the increase in risk of extreme precipitation actually scales at a much greater rate than what we see if we do downscaling with regional climate models or anything we do in statistics. And so that suggests that also you can only get it when you get all the full physics and you're doing it at a high resolution. You get some of these surprises that we don't otherwise see through all the other techniques that we have. So I think the next couple of years also are going to be about what is lost, what is gained when we go to these different high resolutions, what questions you need to answer with different types of data. And that sophistication is going to drive how we build some of our risk models, how we build the information across the United States for building codes, everything else. And we we have pathways to moving to much higher resolution for our models. And it requires some time to build out those physics. And as Bob said, some of the observing systems need to be able to address those problems too. And there will be field campaigns around that. So we have these pathways, but the really big thing we'll be asking a lot of the hard questions is, for the financial sector, what are the questions we need answered? What type of data do we need to answer those questions? And then designing the science to be able to adapt to that. And as part of that, from the executive order signed in May of 2021 on financial climate and financial risk, there is a roundtable held by the National Academy of Sciences specifically on the problem of bringing climate information into macroeconomic modeling. I welcome all who are listening to this. I think many people would be interested in hearing. There's always a public part of those meetings about how is macroeconomic modeling changing, how does it need to change with climate, and trying to spur innovation in that. And I will say, coming off of New York Climate Week last week, where I sat on panels with many macroeconomists across Wall Street, vast majority of them said that they're not bringing climate into their data yet, because
right.
Just the field doesn't have that.
Yeah, well, and to that point, I mean, and this has been something I testified 1.5 years ago about, is that the climate models, what you were just talking about earlier, are much further along than the so-called integrated assessment models that take all the socioeconomics into account, with those physical outputs. Those models actually are fairly simplistic and haven't changed a whole lot in the last 25 years, the DICE models and these other things that are out there. So if there's going to be innovation that has to happen along with the climate models, it has to, as you said, it has to be, how do I take the banks and other financial services companies are making hard money decisions. Bob said it earlier. I mean, the financial scenario analysis that they're doing only goes out 9 quarters, because that's about the horizon, right, of what banks have to deal with on their balance sheets and whatnot. In this case, once you get beyond that, you're kind of in the land of somewhat of the unknown. And particularly when you compound that with estimates of damage effects coming out of these IAMs that, are based on simple 1-2 factor models is not going to cut it in the long run. So totally with you. That's got to happen. Tim?
Yeah, let me just add something to what Cliff said. I mean, first off, what the banks are more concerned about is the integration with the financial modeling, not the macroeconomic modeling. And so that's why Cliff and I have been doing some research on trying to extend the model to sector-specific asset returns over the next 10 to 15 years, driven by some of these climate models. And what I mean by sector-specific would be, not only the S&P 500 as a whole, but what about the energy companies or the financial companies or the real estate companies and so forth, trying to get a little more resolution into the market analysis. And so, yes, the macroeconomic modeling is important, but we're trying to move this integrated modeling more toward finance than economics.
Yeah, definitely. And a climate VAR, if you will, right? Looking at the tail risk of those asset return distributions. So I want to switch gears a little bit if I could. We could spend a long time on this, I suspect. But I do want to switch gears a little bit and turn to the public sector for a moment. And maybe, I'll start with you, Sarah, or if anybody else wants to chime in here. What are some of the best ways federal agencies can support states without having to reinvent the wheel or, conflicting with state actions that are already going on in those areas?
Yeah, so it will be different by every single state because they have faced different issues. A large part of what we're doing with our Climate Ready Nation strategy is making sure that we are bringing information to the states and the local groups to be able to get the information that they need. And so that is done for us through our Sea Grant program for anything that is coastal, making sure that they have the information they need for coastal resilience, dealing with ocean acidification. Sea Grant works with the states, but also local communities on doing that type of work. We also have our CAPRISA program, which has regional centers across the United States And they work closely with all the communities to make sure they have the information they need for the decisions, but also giving technical support for those types of decisions that need to take place. And so it's from our standpoint, we are putting the information out and making sure that we're then working with those local communities to get what they need, and then having that feedback within that. And then there's other broad national programs that we bring together across federal government on certain types of specific perils, like heat.gov, giving information on heat. And then there's case studies of how individuals respond to it and build heat resilience plans, either in cities or states. And then people use that to then build their plans. And then we also have through drought.gov and NIDIS, information on drought. And again, it brings the entire federal community of information together, and gives planning, gives guidance at the local level.
Interesting. Tim, I know you're doing a lot of interesting work with both the state of Maryland and in conjunction with some of the federal agencies too, right?
Yeah, and Sarah made a really good point right at the beginning, recognizing that some states are more active in this space than others, and some states like Maryland are extremely proactive. But I think there also will need to be coordination across federal agencies as well. From I'm an air quality scientist, from the air quality side of things, the states are very active by law, but the work is predominantly with the EPA. In terms of states developing regulations to meet the federal air quality standards, but there's already these partnerships at the state level, the academic level, the community level, and regional organizations as well. So there's already that infrastructure, if you will, to work with to make the community level connections, but it will require, this is just from my view from the ground up, making sure EPA is working with NOAA, is working with NASA. NASA is getting much more involved from their perspective, developing new satellites and other tools. And we want to make sure that across the federal agencies, even just across state agencies, because there's not always best communication between different agencies, those who work on air versus those who work on the water side of things. And where I personally think we're going to need a lot of coordination is at the interface between the land and the water and the air. Water brings us all together, but in the past, people focus on the air, they focus on the water, some focus on the land and the geography. But what I'm seeing more is this recognition and need for all meeting in the middle, kind of a more holistic approach. Because at these margins is where a lot of the population is, and also a lot of risk. So this is just from my perspective, seeing we're going to need coordination at all levels, but across the federal agencies as well.
Yeah, I mean, it hits home for me because I live right along the Chesapeake Bay here, and we had that tropical storm that came up the East Coast last week, and it flooded areas of downtown Annapolis. It hit Cambridge and on the Eastern Shore here. And so, it's not just about the states, right? It's a local issue. And you're talking about local governments at times, particularly over here in the Eastern Shore, that are really strapped for resources, don't have any of this kind of expertise that you all bring to the table, and then some, and just trying to figure out how do you harness all the power of what goes on in NOAA and EPA and Maryland Department of Environment and all these other places with the power of the universities to kind of help these local communities out. I mean, are there examples of that going on today that you can talk a little bit about?
That is what Sea Grant does for us, is bringing together those different groups, particularly in the coastal regions, to bring together the coastal managers, bring in the university expertise, create funding programs where it will bring university faculty to do the research, but then it also connects with the local managers, local cities or states, and they also actually bring in dollars as well. So it's also a way that you have the federal dollars, the state dollars, the local dollars all going into the research and developing plans in those locations. And then also through the way, with our grants on coastal resilience, we just put out in April $562 million around coastal resilience planning around the country. And many of those applications were consortiums of people going for the funding. They received technical support, but then going for that funding to do those projects that would be a nonprofit plus engineers plus university plus local groups coming together on those plans to then execute them. And I think increasingly with the issues we face from climate change and climate risk, it will require many of those different types of groups coming together. And so that program that I mentioned in Coastal Resilience had much more interest than we had ability to fund. And I think we will need to be smart about figuring out how we fund these projects, but then also how we build the capacity across the United States to do it, so that there will be federal funding and there will probably be local, and there will also be need to access capital markets and educate private investors of how to invest in resilience too for long-term resilience communities as well.
I
Yeah,
think-
I'm-
Yeah,
Go
let
ahead.
me add something, another example to what Sarah and Tim have said. There was a collaboration announced a couple of years ago involving the American Society of Civil Engineers, NOAA, and the University of Maryland to create methods for incorporating climate science into building codes. We are going to need improved building codes to provide resilience and so forth, particularly in these high-risk areas. And earlier this year, there was a workshop that NIST, the National Institute for Standards and Technology, got involved with this collaboration. And there's a report on the internet that you can download about climate science incorporated into building codes. And this will be something that the various states and local communities will need to adapt to their building codes, again, particularly in these high-risk areas. But I think it's a very good model of university, industry, and government collaboration, and could serve as a model for other areas going forward.
Yeah, and with that, we're not only providing the data that we already have to help guide ASCE in their development, we also are funding, again, through IRA dollars, the development of new science to address the problems that they're facing and questions that they have, to be able to create the science innovation that is needed to answer the questions that ASCE has to build out those building codes.
Yeah, one of the things you touched on there, Sarah, is near and dear to my heart on the capital market side is the potential for new let's just call them climate derivative instruments to come in. One of the things that weather derivatives have been out there for some time for temperature, rainfall, whatever. It's not a very well developed or liquid market at this point, and it's in part because the pricing of those kinds of instruments is a little tricky, and there's only a handful of geographic areas over the United States that you could actually kind of buy or sell. So it would make a really good hedge if you did that. But trying to kind of build out, I think what we talked about earlier with the improvements in the climate models themselves could help improve the ability to bring more or other new kind of climate derivative instruments into the marketplace beyond what traditional reinsurance can provide. Back to that issue that we're talking about earlier, that sector in particular with insurance is really struggling with a lot of the P&C losses that are going on, right?
Yeah, and like the innovation in that space that we're seeing in parametric insurance is it's advancing really rapidly, particularly in areas of flood and wildfire. And we, through our small business innovation research grants, we've seen some of those come through. Of they're either taking data, government data that's available, and being able to structure their parametric insurance off of that, or they're creating new sensors to be able to have triggers. And some of that innovation also may become more important also post-disaster recovery, because the speed to payout for some of those structures is much faster than traditional insurance processes. So also the innovation that's happening there may also innovate for post-disaster recovery, rebuilding, and redevelopment. So I'm really excited about that innovation, and I would say that's in the climate adaptation space of science and innovation that is occurring and needs to happen more.
Yeah, absolutely. I think that's where we've got to head in some sense. Tim, did you have a comment on this?
Well, the funding that's becoming available through the federal agencies is going to be incredibly impactful. In the meantime, we should also look for opportunities Bob was talking about and Sarah's talking about, like through the IUCRCs, these opportunities where everyone may have small pots of funding that we can pull together to also be impactful. And this is where going back to partnerships with the public sector, based on the interests of specific stakeholder communities, if we can pool funds, we can do very effective work answering some of these fundamental questions. But it's going to take a lot of communication, and just speaking from the academic side of things, the willingness or openness from the scientists to move into this space we don't necessarily have the background and training for, of like communicating outside of the sciences and developing new tools and language, simply just to get to the point. Cliff, you and I have faced this directly, you and I talking to, like, what are you saying, what am I saying, and the acronyms, and encouraging scientific community, encouraging the agencies and academic institutions to allow scientists to kind of meet the stakeholders directly and find opportunities to pool our resources. I think that's going to be key moving forward, especially at the regional level.
Well, I understand, Sarah, you've kind of been at the intersection of that. One of your previous experiences was with one of the large banking institutions, where you were kind of right at the vortex there of trying to kind of communicate what's going on in the scientific community around climate change to the finance and risk professionals, right?
Yeah, and I will say, every chief scientist has had a background that has been the background of the moment, and that was why I was recruited to come back in as a presidential appointee, was to bring that intersection understanding of how science is being used to help us make sure that our science is getting out there and is being used, and we're building the partnerships that we need to make. But then also we're innovating towards what we see as the future needs that are developing. And I think that fundamentally is a transformation across all of science and government science and climate at the moment, is that for a very long time it was about generating information and knowing what the future was holding, because there was so much uncertainty. But now we're at a point where we have a lot of information, we have a lot of tools, and we need to make sure that we are getting that information into decision makers, that they're making good decisions, that they're able to have access to that, they're able to recombine it with other data types that are non-science, to be able to make the decisions they need to create insight. And we need to accelerate that. And we also need, in government, with all this information, we also need to know what that means and how do we respond to it, and then what do we do with all of that. And it is a major priority of mine, of making sure that is taking place, because I often say the value of our science is only fully unlocked when it's actually used. If it's just off on a shelf for a rainy day, it's not reaching its full potential.
Very good insight there, for sure. This point about this intersection, again, a good example of that is institutions, again, credit investors that sit on top of whatever loans, say mortgage loans or what have you, trying to understand the impact of, let's say, a major natural disaster, say a hurricane or a flooding event would have on the likelihood that a borrower will default, and upon default, what the severity of loss will be on that property. That's a pretty important thing. And until recently, right, everybody's been using all the borrower loan product kind of information, but then trying to take real-time information as that hurricane has come over those properties, and knowing sort of wind speeds, rainfall, all these other things, and building that into helping explain those models. That's where I also see some of this data and some of this modeling that you're talking about has got to make it directly into those people that are actually building on the ground those kinds of tools, so that you can project your credit losses better. Say, okay, we just had this storm. What's our likelihood of default over the next, say, 24-month horizon based on what's happened, right? We were doing that back in Katrina when I was at one of the institutions back at the time, and it was really, really hard to do. And it was a lot of subjectivity in doing that work. So.
Yeah. And part of it is that, when you look at the historic data is no longer a guide for what the damages of the future will be, because increases in certain types of magnitudes and probabilities of events, but also if you're location-based or location constrained, events are also happening in new places where they haven't happened before, because there are shifts in where these certain types of events are happening, where the range that they can occur is changing. And we're also starting to also have the emergence of certain things that we call climate surprises, things that have not happened in the past that are starting to happen. Like an example of that is hurricanes in the Arabian Sea, where our climate model started saying that you would generate hurricanes in this region that didn't have hurricanes before. And then suddenly we started seeing them within the same time period that we were publishing the studies of that. And there will be more of those. And that's part of the reason we also, the climate modeling side is important to have that climate modeling and to be able to advance that physics dynamics based information. Because if you're training all of your models on historic data, you will not capture those climate surprises.
Absolutely. Absolutely. As we knew from the financial crisis, where we were training our data on historic information, and we never expected to see a 2008 style crisis. It wasn't in the historical record, at least back what we had. If I could, I'm looking at the clock here. We've got about 9 minutes left. I want to leave some time for Q&A. I would invite anybody who is attending today, if you'd like to drop a question in the Q&A for us, we'll be more than happy to pick it up. I already see that a couple of questions have come in, and I'm just going to pitch them out here to the panel here. And if somebody wants to pick them up, that's great. The one we have here is we have a lot of excellent work that has happened to document the problems we face regarding accelerating climate risk globally. Regarding solutions, for each of you, what's the single best idea you might champion that can help combat this? That's an interesting one. I'm going to start up here on the left, at least on my screen, with Bob. What do you think would be the best idea that we could have to help champion, the issues with accelerating climate risk globally?
Well, I think the biggest thing I'd like to see is progress on these seasonal and interannual models. The climate community needs to get a lot more credibility for these models with respect to the banking system. And if we can't engage the financial services sector more broadly in climate risk mitigation and adaptation, we aren't going to get there. And although there is progress, there is rapid development, it is still small compared to what it needs to be. And so getting these models more credible and interfaced more effectively with what the banking and insurance companies need, I think is absolutely critical.
Sarah, what do you think?
Yeah, the big part of my job, I think a major important thing is figuring out what is the new type of data sets needed to build these new types of models that we need of climate risk, and then putting the smart people into that, and also developing the workforce to be able to do that type of work, to be able to advance it. And in discussions I have over Climate Week last week in New York, where I spoke with MSCI and S&P and insurance companies and on a bunch of investor panels about what is the future. That's what everyone was talking about. Everyone was talking about climate resilience adaptation. We need to figure out how to bring the information in, and we need to build the new structures. So I think everyone's aware of the problem, and at this point, we just need to make sure that we're developing the science and incorporate it into the critical models as fast as we can. And also, an important piece of the communication too that I'm starting to see is needed is the science of this is also going to continually evolve. So we need to build it and build the systems and bring it in, but we need to have expectations. There may be reductions in uncertainty about what the future holds over time, and that what we build needs to be adapted for that new science as it comes in. It will not be static where you do it once and then you're done. Yeah. And so remembering that there's going to be an adaptive process, that also the science for these specific problems, there's stuff that's off the shelf that people are pulling now, but that's going to evolve in time. We need to all be fluid, innovative, and be ready for that type of retrofitting over time that needs to take place. Got
it. I want to hit, there's a question here that's come up that It looks quite timely, given everything that's happening up in the New York City area. He says, so heavy rainfall in New York has severely disrupted the subway system, and the governor declared an emergency. Nonetheless, people here weren't warned until this had already happened, meaning many were stranded mid-commute. I think we've seen that before in other times. I was wondering if Sarah or someone else on the panel could speak to whether real-time modeling still needs work to provide actionable data on extreme weather, especially extreme precipitation. So Sarah, I'm going to go to you on that one.
I do not want to fully comment on things as they're unfolding because don't want to speak for the National Weather Service right now. I will say that there is a flash flood warning still continuing in parts of New York into midday and later tomorrow. On the weather forecast, there's information and that is put out to emergency managers. And I think as we deal with problems we've never dealt with before, we need additional communication about how to deal with the incoming warnings that are for systems that we haven't dealt with before. Because society and the infrastructure that we have right now was not built for the climate that we're dealing with today. And so if you get certain types of information, you're saying, well, this is what it was like in the past, you might be facing something that's different. And so that communication needs to take place. But I direct people to weather.gov to get their official NWS weather warnings for where they are located.
Understood. One last thing. Hey, Bob, another question that came up is, what would be the impact of the Atlantic circulation collapse? Sounds like a bad thing.
Yeah, that would ruin your whole day. Well, there would be a number of impacts. The Atlantic circulation, one of the major impacts of it is that it brings warmer water up from equatorial regions to higher latitudes. And the Gulf Stream and other parts of the Atlantic ocean circulation patterns are critical to maintaining temperatures at reasonable levels. If that were to collapse, I mean, it's very difficult to say exactly what might happen, but some of the risk would be that temperatures in Western Europe could drop significantly and go back to levels that were seen in the 1600s, 1700s. They call it a mini ice age. So that would be one possible effect, but there could be others too, depending on exactly what the collapse might be. Now, one of the things leading to this possibility is that as the glaciers in Greenland and other high latitudes are melting, that's bringing more fresh water into the ocean, and that is tending to have some disruptive effect on the circulation. It's not major, and I don't think this is an immediate risk, but it is something that scientists are continuing to watch carefully.
Tim?
Yeah, if I could add to this, it's also important to recognize that there are natural variations in the climate cycle, one of which is the variation in the Atlantic circulation through the Gulf Stream. And in papers I've read, it's like 70 to 90 years as it goes through this cycle. The climate models, the IPCC reports don't predict there will be a complete shutdown of this circulation, but even a slowdown could have potentially catastrophic impacts on supply chain, fisheries. You could start freezing in ports that traditionally have warm enough water that they're ice free. And when you see in these regions also don't necessarily have the infrastructure to deal with snow. Like they don't have salters, they don't have snow plows, railroad tracks get frozen or sometimes break and they're extreme cold. And yeah, how do you plan for extreme events that have never happened? You can't model things, or it's difficult to model extremes that you can't train based on data.
Yeah, no, that's good.
Also, to add to it, there was even a study that came out this month from the Atlantic Oceanographic and Meteorological Laboratory, which AOML, which is in Florida NOAA lab, showing that even the slowdown of the AMOC leads to increases in flood risk along the western boundary of the Atlantic, which is the east coast of the U.S. So even the slowdown of this increases flood risk along the coast as well, and that is something with sea level rise plus subsidence in certain areas. It's becoming an increasing issue and concern of the coastal communities.
And to
Yeah,
add to
right
that,
now
if
the
you-
concern is that the water temperatures are too warm.
Yep.
And that's
Yep.
affecting, in fact, one of my favorite dinners is Maine lobster. And the lobster fishermen, well, the lobsters are going north because the water is too warm for them. And that's affecting the lobster fishing industry.
I tell you, we could spend a lot more time talking about these fascinating topics, particularly to a non-scientist here, but I'm afraid we'll have to end it right there. I want to thank all of the panelists, Sarah in particular. Thank you for taking the time out, which I know must be an enormously busy schedule for you. Bob and Tim, as always, appreciate it. I'll remind everybody to join us on October 18th for our next installment of the Risk Leadership Series, where we'll be talking about the outlook for commercial real estate with the head of JP Morgan's commercial real estate division. So thank you, and appreciate you attending this event.